Hello friends, get ready to learn physics at HVHP Institute of Postgraduate Studies and Research Study. Myself Dr. Harshal Devta and I welcome you all for this lecture. Today we will focus on some very basic concepts of what is frequency, what is wavelength, and then a basic introduction to the electromagnetic spectrum. The electromagnetic spectrum, it is a range of frequencies and respective wavelengths of different electromagnetic radiations. It is just compilation of all the electromagnetic radiations. Now these electromagnetic radiations comprise like the sunlight, the microwaves, the radio waves, etc. And this particular spectrum is having a wide range of frequencies going from below 1 hertz to more than 10 raised to 25 hertz. So it is a wide range. Another thing is the whole spectrum is divided into separate bands in an increasing order of the frequency or say decreasing order of the wavelength. Now this increase and decrease shows the inverse relationship between the frequency and the wavelength, which is given by f is proportional to 1 over lambda, or f is equal to c by lambda. So first of all, let us understand what is frequency and what is wavelength in a simpler manner. Frequency is the total number of objects. It is just a number, that is 5 apples, 10 balls, 30 bats, etc. So it is just a number. On the contrary, wavelength is the dimension of an object, right? For a wave, it is the distance between two successive crests or two successive troughs. Okay, a taller person has a longer wavelength and a short person has a short wavelength, for your understanding. But before going into it, we can just have a figure, a theoretical figure, which shows two kind of waves, a red wave and a black wave. Mind it, the color here just is to understand, right? What we do is next, we fix a region of study. Okay, now for the red wave, we can see that it is only 1 lambda of this red wave that is covered in the field, whereas for the black wave, we have 1 lambda plus a half more. So here what happened? The lambda decreased, but something increased. Now this something is nothing but the frequency. Okay, taking another example, suppose I have a disk wherein I fit a particular size triangle in it. Now if I take another such disk of the same size but reduce the size of the triangle, then I can place 3 such triangles or even more in the same given disk. So in terms of physics, what I did is I decreased the wavelength and the frequency increased. Okay, I hope the concept is clear now. Now switching over to the electromagnetic spectrum, we can see the beautiful electromagnetic spectrum here, which ranges from the radio waves having the wavelength of approximately 10 raised to 3 meters up to the gamma ray region where the wavelength is approximately 10 raised to minus 12 meters. These pictures here can let you understand that how long are these waves or what is the actual size of these waves. Say for example, when we talk about the radio waves, these buildings which are of the order of 800 meters or say 1000 meters, so you can just imagine that one single wave of radio wave region is of that particular size, and definitely because of this the frequency has to decrease and it is having the lowest frequency amongst all. In the same manner, the gamma ray is having a very low wavelength and therefore its frequency is enormous, it's huge. Okay, so this is the electromagnetic spectrum. One more interesting and a sad part is we humans are only able to see one particular region of all, that is the visible region, and hence its name is the visible region. All the rest regions are not visible to us, right? So this is about the electromagnetic spectrum. Now let us give a brief outline of each individual region and its applications. Moving on, First of all, the radio waves, which are having the longest wavelength, these waves are captured by our electronic devices like radios, TVs, etc. You can just imagine that if we didn't have radio or TVs, and if our human eye had the capacity to see these waves, we could have watched all the TV programs in air, right? But since we are unable to see these radio waves directly, we need a device like a radio or a TV to capture these radio waves and convert it into the visible region. So moving on to the next region, the microwave rays. These are very well used by the ladies in our kitchen, the microwave which cooks your food. Another, they are also used by the astronomers to learn about the structure of the nearby galaxies. Shifting to the next region, the infrared waves. It is also called the hot light. These are detected by the night vision goggles, which pick up the infrared light emitted by our skin and objects with heat. Many times in defense, when warfare goes on at night, these infrared waves play a very important role. Right? Next, the visible waves. No need to explain much. This is the only region which we can see, and the sources are light bulbs, suns, stars, etc. The next region is a bit harmful region to enter, that is the ultraviolet waves. This bluish radiation is also emitted by the sun, and it is the solo reason behind the skin tans or the sunburns. So it is a bit harmful region, so we'll stay away from it right now. The next region is again a multi-purpose region, that is the X-ray waves. The multi-purpose radiation used in medical field, the security systems to see through the luggage baggages, containers, etc. So a very important rays. The last region, the gamma rays, which is having the shortest wavelength, but because of its very high frequency, it becomes the most energetic radiation. Doctors use gamma rays techniques, imaging techniques, to see what's going on inside our body. So friends, each and every region of the whole electromagnetic spectrum is important to us, this or the other way. Okay, so that's all, and we just discussed a brief outline of what is frequency, wavelength, the relation, and the introduction to electromagnetic spectrum. I hope you enjoyed the lecture, and that's me and my institute. Thanks for watching. Have a good day.